as I said, I've been working with water for a long time here at UK. My master's degree was a very interesting degree because it was interdisciplinary. It really helped me out in dealing with water because it is so multifaceted. And that's what makes it interesting to me. I've got about 30 minutes presentation here, but if you want to stop me at any time, just go ahead and do that. If you want to save the questions for the end, that's fine too. Anytime we're talking about water quality, you think about pollution, and the Clean Water Act was passed in the early 1970s. The definition in that act was man-made or man-induced alteration of the chemical, physical, biological, and radiological integrity of water. Now, that seems pretty simple, but what is the integrity of water? And the problem becomes the usefulness of water depends on how you're going to put it to use. And so Kentucky defines a total of 538 separate pollutants that they identify. It goes on for 10 pages, there's about 50 per page. EPA actually identifies about 1,500. So there are a lot of chemicals, a lot of things that can be in water that are pollutants. But luckily, when we talk about water quality in Kentucky and in the Kentucky River, it's usually much fewer contaminants than that. In terms of quality, the word quality comes from the Latin word qualis, and it talks about the characteristics or the attributes or what makes it special. And so when the general public asks you about quality, normally they ask me, they say, well, is it good or is it bad? That's quality. And that's all they want, black or white, good or bad. And as I said, the answer is typically dependent on what the use of the water is and how you intend to evaluate it. So Kentucky designates several uses for water. One of them is warm water aquatic habitat. Another is cold water aquatic habitat. Primary contact recreation, which is based on pathogens or bacteria. And primary contact, go ahead and hand those out. I was going to just do that. I see everybody writing. You don't need to write all this down. I got handouts. Primary contact recreation assumes that you're going to be fully immersed in the water, that the water can go in your eyes, ears, nose, mouth. You may swallow some. Typically it's called swimming, but it could be water skiing, tubing, anything where you get physically in the water. Because in Kentucky the climate is such that it's too cold during about half the year to do that, the standards only apply for 6 months out of the year. The other type of contact is secondary contact, and that's more limited or incidental contact, and that would be like fishing, boating, or even wading would be considered secondary contact. And those standards are enforced the entire year. Domestic water supply is an additional use, typically in terms of water quality for a supply in surface water. It's odor and taste issues rather than chemical quality issues that's evaluated for water supply. There are maximum contaminant levels for drinking water, but those are for the finished water, not for the supply. So that's why they don't worry about that in terms of the designated use. And finally, there's fish consumption advisory, or I guess there's an outstanding surface water resource. Kentucky designates certain streams as outstanding resources. It's based on the community that's found, the biota that's in the streams. Indicates that it's a high quality stream. And obviously for those streams that are designated that, the goal is to not let them become degraded. So in a while I'll show you where some of those are. And finally, the fish consumption advisory. It's not really a water quality standard because the fish live in the water and because they pick up the contaminants from the water. It's considered a designated use related to water. Yes?
Quick question too. How are the designation as a wild river related to the outstanding state resource?
All the wild rivers would probably be outstanding state resource waters, but not all of the outstanding state resource waters are wild rivers. So they may have some, more human impact in them, but the quality is still such that it supports a good biological community. So in general, there's three classifications. One is fully supporting, one is partial support, and one is non-support. So when I show you where all this information is found, it'll generally be in those four categories. It actually gets a little bit more complicated, but for most uses, these are the three categories. Now, I was asked to talk about the issues in the watershed, okay? And this is the sources of pollution that Kentucky lists as the practices and activities that cause pollution in surface water. And you can see it's a broad list. There's 175 total issues. I don't have time to go through them all here, but I'll show you where you can get this list. But you can see that there's a variety of things. You know, we hear about agriculture, we hear about mining, we hear about runoff, stormwater runoff in cities. But all of these different activities have a possibility for affecting water quality. As I said, there's a total of 175 of them. 15 of them don't fall in a category, but the rest of them all been kind of broken out.
When it's another question, so under agriculture, is that 20 different activities or 20 different pollutants, 20 different activities?
20 different activities.
Okay.
And I'll give you an example here. I picked one that's probably not going to offend anybody. It's marine, okay? Unless you order marina, you're not going to care, but it gives you an idea of the kind of detail. You see that there's a code number for each one of them, and so in the reports, there'll be a code if they are identified as a source of pollution. And it can range the gamut from building boats to maybe cleaning up boats or scraping them, painting the hull, dredging operations in the marina to keep the depth deep enough so that the boats can get in and out. Fueling, if you've ever fueled your own car, you know that it's real easy to drop a drop or two when you take the nozzle off the tank. The same thing happens with boats, only it falls right in the water quite typically. Shoreline erosion, most marinas have no lake zones. They reduce the speed of the boats, but still with all the traffic, there's a lot of wave action. And so sediments coming from shoreline erosion is a problem. Pump out releases, a lot of the big houseboats have tanks on them for sanitary waste. They have bathrooms, and so periodically they have to go to the dock and download. And again, they can spill a little bit. They can have a few drips or drops in the water. Some of the houseboats don't have tanks, and so they discharge directly into the water body. There's also, for larger boats, tugboats, for instance, that push barges, they have bilge pumps. And that's to pump out the water that may leak into the hull or splash over the side. And of course, that can pick up oil, lubricants, fuel, any kind of dirt that's in the boat. And then finally, even the process of taking boats in and out of the water, dry docking them, storing them over winter, can cause. So out of the 175, that's 9 of them, and that's the 9 that are related to marine. I will give you the list that has all 175 here eventually. So where is all this information found? Kentucky provides an integrated report to Congress every 2 years. There's a website that you can go to, and if I can do it here, I'll go there, show you what it looks like. And as you see, the reports are done every 2 years. There's generally a summary document, text document. There's 2 big volumes of text. There's 2 large spreadsheets, Excel spreadsheets. So, you know, it's a lot of good information, but it's a little bit hard to use. Let me see here. So that lists all the different documents. The cause and sources document there is what includes the 500 and however many pollutants, and it also includes the 175 practices and activities. So if you're interested in what types of things cause pollution in Kentucky, that's a good place to go. It's just a Word document, so it's easy to access. So every year, Kentucky samples streams in the state. Once every 5 years, individual basins within the state are focused on. So So for example, the Kentucky River in 1 year will be the main focus for sampling. There'll be additional samples. So if you're interested in the Kentucky River data, what you need to do is find the report that has the focus year, and you'll have a lot more data for the Kentucky. There's about, I think, 10 or 15 years worth of reports online. It's a lot to sift through, and so I'm going to show you a little bit easier way to get to some of that information. Now, I said there was 3 different reporting categories: fully supporting, partial support, and non-support. It gets a little bit more complicated than that because there are different categories like primary contact recreation or for the aquatic habitat. It's possible that a segment of stream meets one category but not another. And so like code 2 there is that any assessed use has been met. They didn't assess all the uses, so they can't say that it's good for everything. They can just say that it's good for what they checked. So all those codes are in the reports. So I was supposed to talk about issues, so I'm finally getting to the issues. For the aquatic life, the main issue in 2012, this is all based on 2012 data, which is the last report that's online, is sediment and siltation. A lot of people have a hard time believing that basically dirt in the water is the leading cause of pollution in the state of Kentucky. Basically, that's what it is. A lot of fish are predators. They got to be able to see their prey. A lot of mussels and things that are special to Kentucky, for instance, the Green River Basin has a tremendous mussel population, but they all are affected by excess sediment in the streams. So that's the #1 leading cause. The second one for aquatic life is nutrients and biological eutrophication. So, you know, fertilizers can come from a number of places. They can come from farm fields. Probably in our cities, people put a lot more per acre on their grass than what the farmers use. And so that can be as big or more of a problem in some cases. In our developed urban areas, many of the sewage treatment plants are older and don't remove as much of the nutrients as they might. And so even though we have methods for trying to control the nutrients, urban areas can be a big source of nutrients. So for the aquatic life category, you know, sediment, siltation, and nutrients are the biggies. Cause unknown. I know you earlier this week you looked at some macroinvertebrates, and if they told you that some of them are pretty tolerant to pollution and some of them aren't, well, they can tell that it's impacted because the intolerant ones are gone, but they don't know why they're gone. So they don't know what the cause of the impairment is, but they know that it's impaired. Okay, for the primary and secondary contact recreation, the issue is pathogens, bacteria, and in 2012, this is in percentage of assessed stream miles, and you can see that it kind of runs the gamut. The Mississippi River has less than 10% of the assessed miles met the primary, secondary contact recreation limits for pathogens. Kentucky's kind of in the middle there. It's just under 30%. So that means that in the data that was collected in that year, 70% of the miles that were assessed did not meet primary or secondary contact recreation standards. Now, that said, they don't ever assess all of the streams in Kentucky. There's 91,000 miles of streams in Kentucky. And I will show you in a little while what that looks like, because a very good part of the streams are never assessed because they're not big enough. It would just take too much manpower and too much money to do the analyses. And so this is just the assessed miles. So the top 10 pollutants, this is the list of the top 10. And it varies somewhat year to year, depending on how much rain we get, things like that. But almost always, the top 3 are fecal coliform E. coli, which affects the recreation, sediment siltation, and nutrient eutrophication. You can see after those, it falls off pretty dramatically. Cause unknown is less than half of what the nutrients is. The nutrients is about half of equal in sedimentation. So the big three in Kentucky, pretty much throughout the state, are always pathogens, sediment, and nutrients. And you may thinking about water quality, that all these, I told you there was a list of 500 plus pollutants. Well, there are all those things, but a lot of those things don't cause the problems that these three do. So, I don't think it's a good idea, unless you're really interested, to start wading into those biennial reports. Earlier this year, the state of Kentucky released a new website. It's got a water health portal on it, and I'll show it to you here. It's got three different sections. The map icons there. The top one is dealing with flooding. So it's not really flooding issue, or not really water quality issues, but of course flooding can lead to some erosion and those types of things. So if you have flooding in your community, that's a place to go look for maps. The second one is the water quality portal, and the third is a Watershed viewer, and that has information about permitted discharges of pollution. It has information about water withdrawal points. It has karst ditrace maps. Kentucky has about half the state that has karst topography, and in some of the areas of the state, the ditrace is conducted from the sinkholes to the springs that they feed. And so if there's any karst in the area that you're interested in, that might be a good place to go to look and see if there's been any traces to link the sinkholes with the springs that they serve. What you do is just click on the icon for the map, and you'll get this disclaimer, and it says, well, this is all preliminary data, and, we don't stand behind it, whatever. It also tells you that Internet Explorer does not work too well. That's typical for a lot of the databases and a lot of the mapping products. So they suggest you use Google Chrome, Mozilla Firefox, or Apple Safari if you can. I think I'm using Internet Explorer here, so it's working at it. It's doing what it can. But if you accept that disclaimer, you get a map. And if you zoom in, try to find Lexington. Okay, you zoom in, you start seeing these line segments, the streams and creeks are either red, yellow, or green. What do you think that means? It's water quality, fully supporting, partially supporting, not supporting. And also, if you click on a stream, for example, I'll click on South Elkhorn here, you'll see these icons. You'll see that there's a fish, that's the aquatic life standard. It's partially supporting for that. You see a swimmer, that's primary contact. It's not suitable for primary contact. You see the secondary contact is fishing. Okay, you can do that. It's safe for that. The one that's the water faucet is water supply, and the fact that it's not colored means it's not been assessed for that purpose. So there's no data for that. And the other one is the fish consumption advisory. So it was not assessed for the fish consumption advisory. So any place in the state of Kentucky, you can go and click on the stream segment. You'll notice that here in Lexington, most of them are red. Why do you think that is? It's urban. It's largely pathogens. You go over to Louisville. And you see it's the same thing. So, rural issues are not all the issues in the state of Kentucky, obviously.
Can you go to a rural area and show us the difference?
Go to Robinson Forest.
One of the problems it gets to be, Robinson Forest obviously is not going to have a lot of pathogens, but a lot of the areas in the eastern Kentucky coal field do have pathogen problems due to the sewage treatment plants and the straight pipes and failing septic tanks. So Middle Fork Quicksand Creek, that's in the area close to Forest. It's only been assessed for aquatic life, but it does meet that standard. And what I was saying about the amount of streams that have been assessed, if you zoom in, you start seeing all these blue lines. Those are all streams that aren't assessed. So most of the first and second order streams in Kentucky have not been assessed. So if you have a small stream or creek behind your school that you want to know about, the likelihood is that unless it's a main stream or creek, that it will not have data. Now, you also notice that there are stars on here. That's the outstanding state resource waters designation. So that.
I'm sorry.
Go
Are
ahead.
those assessed by Division of Water?
Yes.
Okay, so that's not anything that's done through Water Watch?
No,
That's specifically.
I'm going to get to Water Watch.
Okay.
Water Watch is in addition to this. I want you to be aware, because this is just a brand new product that most people aren't aware that it even exists. It was released, I believe, in May.
Okay.
So,
I can see this as being a very valuable resource for when we come to sub-driving questions for our students. What a great resource for students to start digging into this. One, to be able to identify streams in the area that they could look at. And then also all of the literature that they have. Jim, online, the literature you had talked about, do you think that a 6th, 7th, or 8th grader can make sense of that literature, or is it written at a very high level?
the reports, integrated reports, are probably written at a level that would be difficult. The Watershed Watch website that I'll show in a minute has discussions that are written for the general public, so I would say for 8th grade level, they can find 6th, 7th, 8th.
Okay.
Yeah, I think the state reports are probably more high school or 12th grade level.
I've given them parts of the 2014 Water Watch report, summary report. So just to show them some of the information was in there.
So again, this is what the site looks like. The top icon is the flooding, the middle one is the water quality, and the bottom one has permitted sources of pollution and water withdrawal sites, and those things. But as I said, the state, outstanding state resource is shown in the stars on the website. So now I'm to the Kentucky River Watershed Watch.
Can I just ask
Yes.
one? Can I ask one clarifying
Sure.
question?
No.
When you say water withdrawal sites, can you sort of explain to me what you mean by that?
Kentucky American takes water out of pool number 9 of the Kentucky River. That site will be on the map and listed as a water withdrawal site.
Would there be any other reasons you'd have water withdrawal sites other than public drinking water?
No, and I think the ones that are on there would be permitted sites. For example, farmers can take water out of some of the streams and creeks for irrigation, and they're not permitted unless they're a huge amount of water. And so they would not be on there. It would be mostly utilities for drinking water.
Or it could be some industry.
Or it could be.
That's what I was wondering, if it was
Yeah,
just
it
for
could be a
drinking
power
water.
plant using water for
Yeah,
cooling
okay.
purposes. It doesn't have to be drinking water.
Because I'm thinking about student research projects that
Right.
if they were looking for information about, for instance, how much water does a power plant use? Or where do they get the water from? What streams are being affected by that? That's where they can get that data.
Right.
Okay.
Okay, for the Watershed Watch data, this website was not working on Monday, so I was dreading coming today and having it not work, but it looks like it's going to come up. This is the Kentucky Water Watch site. You can see it's more than the Kentucky River. It's got all the major basins. KGS is in the process of developing this site for Watershed Watch, and they've started the data that was in the best shape was in the Kentucky River, so that's probably the best shape here in this view. You see that there's a bunch of yellow point markers. That's for sites where there have been samples taken recently. You might also see, maybe not so much in the yellow, but in the other colors, you can see kind of ghosty ones in the background. That may be old data from 10 years ago or something. So there may not be anything current, but there may be some historical data. And if you look at the top here, you can search by site number, you know the volunteer that did the sampling, you can do that, stream name. You know, if you type in something like Sinking Creek, there may be 5 of them in the state, and so you're gonna have to sort that out. But you can look by stream basin or by county, and just by county here, I'll go down and show you Fayette County. What you get is a list of the samples that were taken with the ID number, the status, whether it's active or inactive, county, the stream name, where it's located, like the top one is South Elkhorn Creek, upstream of Route 60 near the airport, and it tells the date of sampling. If you just click on View Results, it'll give you a series of icons here for the field data that the volunteer collected. They wanted to make this user-friendly for the general public, and so they kind of put some information in here, these icons. This particular sample, in the 48 hours prior to the sample, there was over 1.5 inches of rain. And so the stream flow information is a 4. That means it was bank full. It wasn't flooded, but it was just about out of its banks. Turbidity is the amount of sediment, which, as you remember, is one of the leading causes of pollution. Here's at a 3. And that's a qualitative. I mean, the volunteer looks at it and says, well, this is as muddy as I've ever seen it, so it's a 3. Or this is as clear as I've ever seen it, it's a 0. It has temperature, pH, oxygen, and conductivity. And as I say, they're a little bit, for example, conductivity. Most of the macroinvertebrates start having problems if the conductivity gets over about 500. And so the fact that it was 480 means it's close to the top of the green area there. And if it went higher, it would start being a problem, and then getting into the red area, it is a definite problem. So that's the field data. You can also click on the tabs here, all lab results, bacteria, pesticides, nutrients, metals, and others. I know that there's no bacteria, pesticides, and nutrients or metals here, but there are nutrients. And what it gives you is a list of the analytes, what they measured, and the amount. And so for any stream that you might want to look up, the data for the Kentucky River should be all there. You can look by county, you can look by stream name, any way you want to try to access the data. And they've been doing this for, I guess, around 15 years. And so for some sites, it'll be 15 years of data. For some sites, it may only be 1 or 2. So it kind of varies. The other source of the same information, but it has some other things that you might be interested in, are the actual annual reports. And they're text documents. They're not searchable in the same way. But what I wanted to show you on those was their discussions. Discussions for the various things like dissolved oxygen. It tells you about what the normal level should be, what the good level is, what it does to the stream, pH, temperature. So these, again, these are written probably at the 8th grade level, so these would be accessible to most middle schoolers.
There's a packet that I handed out to the folks who were here yesterday. When we went to the computer lab, the first one was, I gave a packet that had the created a spreadsheet and had all the directions for Plotly. Then there was a second packet that was actually part of this annual report from 2014, and this data, that information is in that report.
I have a question about
Yes.
the dissolved oxygen. So does the dissolved oxygen have a direct correlation to pH?
Not necessarily.
Okay.
A lot of these things don't have direct correlations, but you might think that's one of the things Carol was trying to do, is look at correlations between different analytes. And for some, dissolved oxygen has a correlation generally with temperature, because the amount of oxygen that can be in water changes with temperature. But not necessarily with pH or
That was something I always wondered.
Yeah.
Well, I might add, under certain conditions, there could be some type of relationship.
Yeah.
If you have a lot of algae in the water,
Sure.
then the algae,
Is creating an artificial pH level.
right, so that could cycle, and so that could kind of cycle with the DO as well.
Okay.
And then it's a daily cycle.
It's a
You can see it
daily,
very easily in the daily data, or in hourly data over a day's time. So this is the sampling sites for 2014. You can see that not the whole basin is covered. The headwaters has a lot in the North Fork, the Middle and South Fork, there's not much data. My guess is, number one, there's probably not volunteers there that wanting to do it. Number two is that the volunteers that were there probably is historic data, but they didn't find anything. And after you've gone there 4 or 5 different years and didn't find any problem, you start losing your incentive to want to go back. Now, it shouldn't be that way, but that's the way people are. Because they're wanting to help, and they're wanting to help identify problems. So you also see that in the downstream segment, there's not a lot. There's a segment in here. Around Lexington and Frankfurt, there's obviously a lot of samples. So depending on the part of the state that you're interested in, there may or may not be data. And again, this is just for the 1 year. There are all the samples for all the years are in the database. Yes?
Would there be any interest in Water Watch working with schools in terms of collecting data? I'm thinking we have some folks here from Grant County and Henry County, and I don't see a whole lot of docs out there.
Yeah, I think there are some teachers that are Water Watch volunteers. And so there
Like
are
the
some.
data our students collect, we submit it to Water Watch.
If you have the training program.
Yeah,
Right,
yeah,
they have to have a training program.
You can maybe to supervise some, I mean, you are ultimately the one held responsible as a
Right.
volunteer
So you
for the quality of it.
yeah, so the teacher would probably need to go through the training.
Oh.
So they do have some formalized training to kind of show you how to do
very,
it.
very similar to what we've done already.
Yeah.
Yeah.
If you're doing
And the other question you might ask yourself is, well, if it's not meeting the requirement of primary or secondary contact recreation, you want to throw your kids in that stream.
Yes.
It probably should be fine.
We don't-
I wouldn't tell you not to do that, but maybe something you want to be aware about, so they may ask you that question, what are you doing with throwing these kids out the stream?
Especially if they have like cuts or something like that. But we have an infamous case, we have someone sampling in Fayette County that had a cut in their leg, and this person got taken to a hospital eventually because he got out of the streets in Fayette County.
So again, this is what the database looks like, the various tabs there, is how you can search for the data. And if you're only interested in Kentucky River, you can do it by stream basin. All the data from Kentucky River. Another resource I wanted to show you, because this day is kind of, I guess, dedicated to mitigation of problems. I was asked to talk about the problems and not how to fix them, but this is a site that the Water Institute worked on, and the reason that it's good is because it has some descriptions also. Oh, it's not gonna.
Well, we can click updates and go through that whole rigmarole. You're welcome to do that
I
if you
won't
like.
I can show you on this. There's this whole section here that's called management strategies. And there are strategies that are known as best management practices. And this particular project dealt with nutrients, which again is one of the top 3. And there are documents there for agriculture, for urban, for a variety of topics, policy, and wastewater. And again, those are probably written at the general population level, probably 8th grade understanding. There'll be pictures there of some of the mitigation techniques, and there'll be descriptions of them. And there'll be some discussions about what the residents of this watershed thought about some of those opportunities. It's very interesting to talk to the general population about methods of improving water quality. There's a lot of interest, but there's also a lot of misconceptions, a lot of people that assume somebody else is causing the problem. And that's human nature in a lot of ways. Another thing you might do if you're interested in mitigation measures is just go to the EPA website. I won't do that now, but there's a search box at the top of that site. And just type in water BMPs, best management practices. LID is low impact development. Those are urban. Erosion, pathogen, or nutrient BMPs. Those are the top 3. And you'll get reports from the EPA that deal with all those issues. You can also just go to Google or Chrome or whatever and type those in a general web search. And what you'll get in those, in addition to the EPA documents, is you'll get vendors or people that have consulting companies that provide services or equipment to deal with it. So you get a little bit different information from the two different places, but I would check both if you're interested in looking for ways to mitigate water quality problems.
Can I just interject just for a
Sure.
second? I'm thinking there's a great opportunity, great options and recommendations. Because I'm thinking as your students are going out and collecting data from your streams, so you get some data. And of course, we talked about yesterday that so you go to a stream once and you collect some data. Do you really know a lot yet? You sort of are collecting maybe some baseline, but you really don't know. So how does this stream change over time? How does it change as you have more water, less water, etc.? But if you do find things that are there, or if you got a WaterWatch data to do some comparisons, you could certainly look at sites like this to find out, well, gee, so what are some things we could recommend to our parents, our community, and things like that, just as ways in which we can just think of water quality in general, and ways that we can improve water quality.
And I think, Becky, this goes a long way to change that misconception that students have that science takes place in 45 minutes. Because a lot of our students are sort of programmed now that science takes place, or an experiment. An experiment takes place in 45 minutes, and it doesn't. Talk to a lot of teachers also that they say, oh, we've got to get through that testing, and we can't do that. Well, you know what, you can. And it's up to us to change that paradigm.
It is,
to do it in the long term.
and it's also just becoming aware. I mean, Jim, you have said it several times. You know, it's oftentimes that, as you said, humans oftentimes will think, well, it's someone else's problem. Someone else is causing that problem. Rather than us thinking about, what am I doing? You know, we talked about our carbon footprint. You know, a couple of years ago, we learned about what a huge carbon footprint we have here in Kentucky. And so you point your finger at someone else and say, well, it's because my neighbor, you know, he wants to keep a nice cold, you know, house in the summertime. Well, probably it's not the whole problem. It's all has a lot to do with educating ourselves and becoming much more knowledgeable about, you know, what is this water quality? Where do we have the water? Where do those things come from? And all of us have a role to play in this. But yet, as we talk about this, Jim, I was talking yesterday that regardless of what we're finding here, I always go back to the analogy of coal. We have lots of folks who are on the environmental side who say, well, we should just stop mining coal. Don't use coal anymore. And I'm always thinking, that's great. So you want to turn your lights on? You want to use your iPad? You want to use your iPod? How are you going to do that? We don't have any other ways other than natural gas and things like that that produce the amount of energy that we need that would run cities. And so it's really, again, becoming educated and thinking about, okay, there are things that we can do and things we can mitigate. And I guess that's the point here. But thank you very much. Excellent. Thank you for your...
I've got just a couple more things I picked up as I was leaving my office this morning, and particularly because you were asking about age appropriate or level appropriate. These are low literacy publications, so they ought to be good for, you know, middle, elementary to middle school. There's one on stormwater. There's one on what is a watershed. And there's one about planting along your stream, pond, or lake, the riparian zone. I know you've looked at that a little bit. These are all extension publications. If you go to the UK Extension site, there are PDF documents. You can download them for free, pay to get them or send off to them. So they have a lot of pictures. They've got some pretty good discussions. Might be good resources for you. With that, are there any other questions? When you looked at the organisms in the water, did you use one of these? Okay, I'm going to give you one of these. This is a document that was created
I never saw one of those, sorry.
through our office, and it has macroinvertebrates. It has the ones that are tolerant and intolerant. You can actually use a grease pen on them and use them over and over again to mark things down. They are covered so that you can take them out and drink with you and not worry about getting wet. So. We just have a limited quantity, but you can have those. We don't have enough to give any quantity. All right, well, thank you all.
Okay. All right. Good, then.
Linda, before you start, we have another guest who's going to speak on a panel this afternoon. This is Ben Krebs.